Hey Denver Cyclones, this is Mr. Pickett, and we are going to be talking about energy today. So we're going to rip through this in a short amount of time so that way you guys can get started. So we're going to quickly review some different types of energy. We're going to move specifically into the things that we spend a lot of time with, which are kinetic and gravitational potential energy. Then we're going to move to conservation of energy, and then we're going to go back into that design, evaluate, and refine situation, because I'm hoping some of you are going to create some Rube Goldberg machines, which if you looked at, I believe, Monday's information, there was about 2 or 3 videos that were examples of Rube Goldberg machines. Relax. None of this stuff is required, but I hope again that you're taking advantage of these learning opportunities. Death is not the greatest loss in life. The greatest loss is what dies inside while still alive. Never surrender. Fantastic quote. Again, none of this is required, but are you really living if you're not experiencing things? So I hope that you're going out there and you're experiencing life. All right, so different types of energy. Boom. So remember, energy is like, what is it exactly? It's usually a number property that's given to matter and radiation. So if I have something that has a lot of energy, that's usually saying that there's a number associated with it, and that's going to something that I can either touch, or radiation is something that I can feel, right? Energy comes in many different forms and continually changes from one to the next. So it's a hard concept to grasp. Energy is usually, when we deal with it as like young scientists, we measure that in joules. And we also know that energy cannot be created or destroyed. And energy has the ability to do work, which is another physics concept. Can you guys think of examples of energy? All right, well, I hope you came up with a couple, right? If you guys remember, there's lots of energy types. There's nuclear, there is like temperature energy, there is geothermal energy. There's just lots of different kinds. So as you're looking at this this video here, you guys can see that wow, we're having a lot of movement, a lot of arrows, and we can see electrical energy that's here. We're seeing energy in the form of motion. We're seeing energy in terms of steam creation, which is in the movement of matter, and it's all doing a lot of interesting stuff. So hopefully you guys are seeing a lot of movement, and a lot of times when we generate electricity, well, we do that by causing something to burn, and that burning substance generally causes water to heat up, and as water heats up it turns to gas, and we can force that gas into some sort of a electric turbine, and that electric turbine can thus create electrical energy for us. When I say create, it's not that I created it from nothing. I started with energy in the first place. And if we go all the way back, there's some fuel source, some gasoline that was chemical energy at the beginning. So types of energy that we're going to be working with mainly, we're going to be talking about kinetic energy, which the equation for kinetic energy is 1/2 times the mass, which is measured in kilograms, times the velocity squared, and the velocity is measured in meters per second. Gravitational potential energy is another type of energy. Some people just kind of take the gravitational word out of it and they call it potential energy. However, gravitational potential energy is more specific. It's talking about the potential energy that an object has when gravity acts on it. So GPE, or gravitational potential energy, is the mass of an object measured in kilograms times its acceleration due to gravity, which on Earth is roughly 9.8 meters per second squared, multiplied by its height, or its distance away from the surface of Earth. And then another type of energy that we tend to work with as well is thermal energy. And thermal energy, it has a lot of different measurements. We're not going to worry so much about that today. I think most of us realize when something has a lot of thermal energy, really hot, or does not have a lot of energy and it feels really cold. And again, can you guys think of any other examples of energy? Okay, so our next segment right here is we're going to take a look at kinetic and gravitational potential energy a little bit more. Right, so kinetic energy again is 1/2 mass times velocity squared, and gravitational potential energy is mass times gravity times height. As we look at these two terms up here, the word kinetic means to move, and that's why velocity is included in this equation. And gravitational potential energy has three things that are very important to it. If an object has more mass, it's going to have more potential for energy. If the gravity or the attraction between the object and whatever it's pulling it, which in our case is Earth mostly, if the gravity is more, then yeah, that's going to have more potential for energy. And then the object's height, right? So as an object gets further away from Earth, there's a potential for more energy because it just actually has technically longer to speed up. So when we think about gravitational and kinetic energy, one of the easiest ways for us to describe it is when we start thinking about like roller coasters. So if you're at the top of a roller coaster, like the biggest ramp you can think of, that's generally where your gravitational potential for energy is its highest. And the reason why is because the height is the biggest. Usually at that point, though, your velocity is next to nothing. And so you almost have no kinetic energy. And as you go from the tallest part of the roller coaster to the lowest part of the roller coaster, you notice that the amount of kinetic and gravitational potential energy will flip. So at the bottom, you're probably going to be moving close to the fastest. So that's going to mean you're going to have the most kinetic energy, but your height is going to be the lowest. And so you're going to have the least amount of gravitational potential energy. It's important for us to realize that these energy sources, at least they're transferring, is a big deal. And that's why we call it energy transfer. So the relationship between gravitational potential energy and KE is usually if you lose GPE, that mostly means your kinetic energy is being gained. So you're not losing the energy, you're just seeing the energy change from one form to the next. You also notice that some of the gravitational potential energy would also be transferred into heat and to sound. So you're never going to get a full 100% transfer of gravitational potential energy to kinetic energy because other types of energy kind of sucks away or takes, I'm saying this incorrectly, some of the gravitational potential energy will turn into other forms of energy, again, like sound, heat, or light. All right, so that's all leading us into this bigger concept of conservation of energy. Right, so here's a great little GIF with Neil Tyson Degrassi, and he's releasing this little bowling ball from the tip of his nose, and he's really not moving, which is important here. And the ball gets really close to his nose, but it actually doesn't touch. And the reason why Neil Tyson Degrassi knows that he's not really in any danger here is because energy can't come from nothing. And so as he pulls that ball to his face, it's got so much energy. It's got so much potential for energy. And as he lets it go, that energy gets turned into kinetic energy and eventually back into gravitational potential. There is no way that this object can actually reach his face because that would require some other input of energy. So yeah, somebody on the other side of the room can actually push the ball and that would cause it potentially to come back to him. But Neil Tyson Degrassi knows that when he lets it go, it probably won't come back to his nose because just a fraction of that energy is going to get turned into other forms of energy. And that's how we lose, in quotation marks, energy. It turns into heat by friction, it turns into sound, it turns into light. So some of the energy as it's converted from one form to the other is also converted into other forms. Here's another example, a ridiculous one where you're sliding in the DMs here, ladies and gentlemen, of somebody that's losing a little bit of height. So they're actually losing gravitational potential energy, and it actually gets converted into movement. But eventually this person stops. So where does that energy go, right? If I can't create or destroy it, so what is it turned into? Well, in this case, he's caused himself to stop, either by touching his foot onto the ground or something, but he's actually causing his hand and his body to actually increase in heat because there's friction that his body's experiencing on the ground. And so he's having gravitational potential energy turn into kinetic energy, and eventually all that energy is converted into other forms of energy. I'm sure those people around him actually hear him sliding as well. Here's another really good example of an object that is moving really quickly, so it's got a lot of kinetic energy, and it's getting closer to Earth, and so it's actually going to decrease its GPE and potentially increase its kinetic energy some more. But because of friction, this object is probably not going to get faster. However, it's going to keep getting closer to the Earth, so it should see its kinetic energy increase. It's not, and instead what we're seeing is that its energy is being turned into light. It's being turned into heat, a massive amount of heat as well. It's a great little picture. All right, so what I'm going to have you guys do is design, evaluate, and refine a Rube Goldberg machine. And if you remember, a Rube Goldberg machine is some crazy device that accomplishes a very basic task. So converting, the idea is that you're going to hopefully convert one form of energy into another one. I'm assuming you're going to use a lot of different forms of energy, types of transfer. What I want you guys thinking about is how some of your energy is going to be lost and how you're going to account for that. I mean, you're going to know if your design worked, if you can actually get it to the end. And I'm assuming some of you are going to have to be creative in terms of how you're going to get that done. Why did you choose some of the materials? And how many different ways can you get energy to transfer? I mean, if I want to open up a door, yeah, I can just turn the handle. And that's just taking my chemical energy and turning it into kind of movement energy as well. But I want you to see how many different ways you can get energy to transfer. Can you make your device more complicated? Did it actually work? Did it perform well? Were there any issues? Can you make the design better in some way, shape, or form? And then refining your device, again, can you make it more complicated? Can you incorporate other students into your design and maybe splice together videos? And can you make your end task like ironic? You know, we're at home. What's something that you do every single day that's ridiculous? All right, so again, some like 3 big pointers here. Again, do it yourself. You can use the internet as inspiration, but try to just use the objects around you. Again, cheap, use old toys, towers, Jenga blocks, whatever, and make it fun and ridiculous. Document your design, and hopefully you guys will hit me back at some point in time. Again, you can follow me and tweet at me or Instagram me at Coach J Pickett. Bye, kids.